I want to start off this lesson with actually a story. And it's a pretty famous story. Now, is it 100% true? I don't know, right? But let's just pretend that it is because it's more fun to operate on that level. So, this story actually involves one of our favorite mathematicians, Carl Friedrich Gauss. And before you get all worked up and start having these weird traumatic flashbacks to Gaussian elimination, don't worry, it has nothing to do with Gaussian elimination. But I just want to actually tell you the story about this mathematician. He was a famous 19th century mathematician and he was known as a child prodigy. And the story goes that when Carl Friedrich Gauss was 10 years old, he was asked by his math teacher to add all the numbers from 1 to 100. And Carl Friedrich Gauss just immediately responds 5050. And the math teacher was astonished. And he asked Carl to explain to him how he did so quickly. Remember, this was before Google or just being able to, ask your iPhone or put things into a calculator. And what Carl Friedrich Gauss then proceeded to show him astonished this teacher. Because here's what Gauss says, or said, I should say. He said, all right, you asked me to find the sum of all the numbers from 1 to 100, which would look like the following. These are all the numbers, and I'm not going to write all of them here, but these are some of the numbers from 1 to 100. You're asking me to add these terms. If I were to take that same series, and if I were to reverse the order, so then go from 100 to 99 to 98, 98, and just write all these down. So we have 3 plus 2 plus 1. So it's the same exact series, I'm just reversing its order. And if I were to then find the sum of these two series, same series, right, but just written in different orders, what do I have? Well, on the left side, I get 2 times whatever my actual sum is of my series. And over here, every single time when I add 1 plus 100, I get 101. 2 plus 99, that's also 101. 3 plus 98 is 101, and so on. So I'm adding a bunch of 101s. Well, how many of these 101s am I adding? Well, that's easy. There were 100 terms in this series, so there are 100 instances of 101. And so then if I just divide everything here by 2, what am I left with? I have the following. I can quickly say 100 divided by 2 is 50 times 101, which is just 5050. Now, this teacher was astonished not just because Carl Friedrich Gauss, at the age of 10, was able to come up with this value so quickly, but what he had proceeded to show here was exactly the nth term, or I should say the sum of a finite arithmetic series with n terms, or even a finite arithmetic sequence. Because what we're effectively saying here is the following. Define the sum of an arithmetic series or an arithmetic sequence. You take the number of terms that you are adding, right? So the number of terms that you're adding, and you're going to multiply it by the sum of the first term plus the nth term, the sum of the first term, let me do that, highlight that, the first term plus the nth term in that series, and we're dividing all of that by 2. And this is the sum of a finite arithmetic sequence. This is exactly what we have here in our notes. So I will never accept any Carl Friedrich Gauss slander, not on this channel, not in this classroom, because what he did there was dope, right? If the story is true. Now, so we can use that formula now to our benefit. Thank you, Carl. So we can then say, all right, the sum of any finite arithmetic sequence can be given as such, right? This is when we know what a sub n is. And when we don't know what a sub n is, if we don't know what a sub n is, we can just sub in the general term or the a sub n term for that. This would be a sub n. That's if we don't know what it is. So let's go ahead and let's try a couple of different practice problems using this, okay? So let's first find the sum of the first 100 positive odd integers, okay? So the sum of the first 100 positive odd integers. So what's the first positive odd integer? Well, a sub 1 would then be equal to 1. And since we're looking at odd integers, the common difference, right, if we're looking at, for example, 1, 3, 5, 7, the common difference is just equal to 2. We saw this in our previous lesson. And we're adding up 100 integers. So there are going to be 100 terms in our series. So the sum of the first 100 terms in our series would be the following. Our n value is 100 times. Again, do we know what our a sub n is? Well, from our previous video, we actually wrote this down from 8.1, but let's just pretend for the time being we don't. We would say then the following. We could say this would be a sub 1, which what we said was 1, plus, and I'll do this part in a different color. We're going to do, or maybe use red to keep it consistent. We're going to go a sub 1, which was 1, plus 100 minus 1 times our common difference d, which was 2. And you can find this separately and just kind of plug in this result for a sub n. Just know that we're finding a sub n right now. All of this over 2. So if I just clean this up a little bit, 100 goes into, or excuse me, 2 goes into 150 times. So this is 50 times, well, what do we have here? This would be 2 times 99. So let me just write this, 2 plus 99 times 2, which is 198. So our result here is 10,000. So I know it looks a little unwieldy here, but just remember all we did here was find a sub n because we didn't actually have that nth term. And if you want to do that separately and just plug in, you can do there as well. Okay. All right. Let's try another problem. This time let's look at a series that's given to us in sigma notation. So something like number 2. So for this one, we know what a sub n is. We're given that. So if I want to find up the sum of all the terms starting with the 10th term going all the way up into the 100th term. Let me just zoom in on that to make sure we understand which problem we're looking at. From the 10th term to the 100th term. Well, first off, what is the 10th term? A sub 10, if I just plug this into our a sub n here, is 25 minus 2/5 times 10, which is just going to be 21. Now let's find a sub 100. That's 25 minus 2/5 times 100. And that's just going to give me, what's that, 25 minus 40, which would be negative 15. Okay? So there's our a sub 10, and here's our a sub 100. So we would say the following. We would say the sum here from our 10th term to our 100th term would be the number of terms we're adding. Well, how many terms are there from 10 to 100? And before you just go ahead and subtract 100 minus 10, which is part of it, remember that if we're including 10 and including 100, that there are 91 terms. So we would say n is equal to 91 over 2. Our first term that we're adding is 21, excuse me. The last term that we're adding is negative 15. So just to be clear here, even though I wrote a sub 1 in our notes, this is always just the first term we're adding. And I should probably go back in the notes and clarify that. So let's actually go back here. A sub 1 is just making sure we understand it's the first term we're adding, not necessarily just the first term of the series. Okay? And a sub n then would be the last term we add. Okay? So if that's the case, just to clean this up, this would be 91 over 2 times 6. So that's just 91 times 3. And that gives me 273. There's my answer. Okay? All right, let's try another one. Let's try number 3 now. For number 3, a little different. We're not in sigma notation, but we know that this is going to be our first term. And we're not exactly sure what term number this is in our series. So I'm going to just label this a sub n for now, right? This could be the 9th term. It could be the 90th term. We're not sure just yet. So let's try to figure that out. We know that a sub n is equal to a sub m plus n minus m times t. So let's put that in for a sub n. So negative 14.3. We know our first term. Let's write 4.2 plus the difference in order. And we can quickly figure out what our common difference is here. Again, if we do 3.7 minus 4.2, we see that the common difference is negative 0.5. So negative 0.5. And if I clean this up a little bit, what do we have? Let's see, subtract 4.2, so negative 18.5. is 0.5 times n minus 1, n minus 1, oops, n minus 1 on this side. And if I divide by negative 0.5, that's just doubling it, so that's positive 37. So n is equal to 38. So the sum of the first, so before I find the sum, just make sure we understand this turned out to be here, this was a sub 38. This was the 38th term in our series. So if we're finding the sum of the first 38 terms in our series, we're going to take 38, which is the number of terms we're adding, divide by 2, times the first term, plus the last term in this case, and the 38th term, so negative 14.3. And if we clean that up, we are going to get, let's see, 19 times negative 10.1, which is negative 191.9. There's our sum of our first 38 terms. Okay? So I encourage you to try something similar now for this example below and go ahead and check your solutions in Google Classroom.